So, hi everybody. Thanks for joining today. I am Taryn Pratt. I am the database reliability engineer at Stack Overflow. You can find me in a few places online. You can read my blog at tarynpivots.com, or you can find me on Twitter at tarynpivots, or at stackoverflow.com. I have a profile there if you really wanted to find me. Today, I'm going to talk a little bit about an issue that we hit at Stack Overflow earlier this year. One in which we were fighting with schema modification deadlocks on a fairly regular basis, or as I like to say, the worst deadlock to deal with. Now, most of you know or should be familiar with Stack Overflow, at least heard of us and our network of sites. This talk isn't specifically about public Stack Overflow. This is about Stack Overflow for Teams. Now, if you're not familiar with Stack Overflow for Teams, a few years ago, we launched the Stack Overflow for Teams product, which basically is a private version of Stack Overflow. It allows you to share your knowledge with a specific set of users, whether it's your small team or your company. Everything's locked down specifically to that team. No one else has access to your content unless it's you or a member of your team. Now, overall at Stack, we're a very hardware lean organization. And it's no different for the Teams aspect of it. Our Teams infrastructure for SQL consists of a 3-server cluster running SQL Server 2019 with always-on availability groups to keep everything in sync. Now, when we built Stack Overflow for Teams, we weren't actually sure how fast it was going to grow because it's a brand new product. You weren't really sure. But we knew we potentially would need to support a lot of teams on very minimal hardware because we didn't want to spend any money on something that we weren't sure was going to be successful. So the decision was made very early on, not by me, I will just say, to use schemas to keep each team separate. So in other words, instead of using a single database for one team, we decided to use one schema for one team. So every single team gets its own schema. We then have multiple databases to support the product. Each database contains 10,000 schemas in it. Good or bad, that means we have tons of schemas that we have to manage across the entire product. Right now, we've got 10 channels.Stack Overflow databases, each containing 10,000 schemas, supporting up to 100,000 teams. And yes, in fact, that is the name of the databases. They are called Stack Overflow or channels.Stack Overflow with some crazy number after it. And it's not teams.Stack Overflow, even though the product is called Teams. The reason for that is far larger than what I can get into for a 10-minute talk. That could be another time. So as I mentioned, we have tons of schemas that we have to manage. So initially, when we started Stack Overflow for Teams, I actually was manually provisioning each team. So somebody would sign up and I went in and executed the scripts. Obviously, we knew that wasn't going to be scalable, so we had to create some sort of a process to provision these things. And create the teams. So what we decided to do is we decided to provision teams ahead of time. And what I mean by that is we would create ahead of time the login, the user, the schema for that team, assign the permissions, give them their tables, views, every single database object that they would need in order to support their own team. This was done specifically because we wanted to prevent the possibility of hitting any race conditions by having multiple teams be created at the same time. And we didn't want to potentially suffer any performance overhead or impact if we had to create teams on the fly. Now, when we provisioned the teams, what we did is we always made sure we had a pool of 500 schemas that were unclaimed and like ready to go when somebody signed up for a new team. And then we would replenish the pool of 500 every 5 minutes on a scheduled job. So for example, if a team gets created in a 5-minute, if 2 teams get created in a 5-minute period, then we would create 2 new schemas, give them their logins, the user, assign us all the permissions, give them any of the database objects, everything like that on this next scheduled run. And the entire process worked great for several years until it didn't. So on March 17th of this year, we made an announcement that Stack Overflow for Teams would now be free for up to 50 users. So as with anything free, we got a huge spike in signups. We averaged about 55 new teams per hour in the first 24 hours after the announcement. That was huge for us. But along with the spike in signups, I started getting a huge increase in alerts on deadlocks that we were getting on the primary SQL Server for Teams. Now, most people probably know what a deadlock is, but if not, deadlock happens when two processes want access to the same resource and they get blocked by each other. And then when this happens, one of the processes gets chosen as a victim and it has to terminate. So I was getting tons of these alerts from SQL Sentry. I was getting multiple per hour, multiple per day. It was kind of ridiculous. In the first 2 weeks after the rollout of free teams, we hit 200 deadlocks, which was a lot for us. We don't get that many. So obviously I had to figure out what was happening and how I was going to go ahead and stop it. In the email alerts that I was getting from SQL Sentry, I noticed that the victim text always appeared to kind of be the same. I confirmed it by going into SQL Sentry and reviewing all of the deadlocks that have been happening. And over again, the victim was always when the application, when it was connecting to the database, it was attempting to set the transaction isolation level to read uncommitted. That was weird because I had never seen anything like that, but that was always the victim. So I looked a little bit further using SQL Sentry and SP Blitzlock to try and get some more information on it. And the winner of the deadlock every single time was when we were granting the permissions during the provisioning process. So the winner was always when we were granting each new channel or team its select, insert, update, delete, alter permissions over and over again. And we were doing this every 5 minutes. So it was happening a lot. Every time we had to provision a new team because we had to replenish that pool, we were hitting this deadlock. So using SQL Sentry, I was able to get the deadlock graph, which was very helpful because it provided a very big missing piece to the puzzle, because then I was able to see that we were getting the deadlock because of the schema modification lock that was being taken by the grant. I knew about the schema modification lock, as a lot of people probably do, but I also knew the evils of it from a blog post by Michael Schwartz. But I had never seen anything like this to this level. So each time our provisioning process needed to assign the permissions to a brand new schema, it took a schema modification lock, and the lock was so aggressive that it blocked any other activity that was happening in the same database, even if it was taking place on a different schema, because the other process was needing a schema stability lock, and those are incompatible with each other. So we had to figure out how to fix the problem. So because this was just repeatedly happening. So we threw around a lot of ideas as to how we were going to resolve this deadlock. We thought about maybe changing the timing of the provisioning process, maybe not doing it every 5 minutes, maybe doing it at night, maybe provisioning a bunch of things with their permissions at night and just kind of doing it at a different time. But we realized all we were doing was just kind of kicking the can to a different time, and we actually had to refactor how this whole process was going to work. So eventually we decided that instead of provisioning everything in a single step, we would make this a multi-step process. So we decided to pre-provision an entire database beforehand. And what I mean by that is we created 10,000 logins, the users, the schemas, and associated all the permissions with those logins for a brand new database in a single step. And then every 5 minutes, we would keep a provisioned pool of schemas that would have the database objects, and it would have its connection string and everything that would be needed for the team. So we're keeping that pool, but basically what we wound up doing is we moved the process that needed that schema modification lock to a database that wasn't being used. So we weren't hitting that lock every time we needed to create a new schema. It basically, we just moved it. You still need the lock. It's just we're not hitting the contention with other processes on the same database. And then as we get close to using all of the schemas in a specific database, the pre-provisioning process will kick in and it'll create another 10,000 schemas in the new database. So it was a very interesting problem for me because I've never seen anything like this. I mean, we have a lot of deadlocks, obviously, at Stack, and they can be fun to debug, and others can be a challenge to solve. They're fun because they're always a little bit different, but this one was completely different because I've never had a deadlock with a schema modification lock. But if you ever run into it, you might have to change the way that your process runs, maybe run it at night or do some refactoring. I have a couple links here to some resources. I wrote a blog post about this if you want to read the blog post instead of me fumbling about talking about it. My coworker, Dean Ward, gave a presentation on how we actually built Stack Overflow for Teams. And then Michael J. Schwartz, he wrote a blog post about how schema modification locks are very evil. So thank you. That's 10 minutes.